At one time, the introduction of a new operation principle to this dump truck became a technical revolution in itself. After all, the monster BelAZ essentially runs on electricity, or rather, has an electromechanical transmission. Previously, and even now, almost all trucks have torque transmitted to the wheels through the camshaft. But here the external forces are so great that the crankshafts and camshafts had to become simply gigantic and therefore heavy, which means they needed to transmit even more torque, and so a vicious circle formed. At that point, the designers decided to get rid of these shafts altogether. The BelAZ is a giant moving electrical power plant. It burns diesel fuel, generates an electric current, and transmits it through wires to electric motors, which are mounted directly on the wheels. These motors drive the entire vehicle. Pitted next to this monster, you begin to perceive the phrase motorhome in a different way. This car is really more like a two-story building. There's even a staircase, a balcony, you could say, and as your home probably does, this truck has air conditioning on its facade. Many think they're headlights, but no, they're actually air filters. Through these filters, the BelAZ monster inhales hundreds of cubic meters of air per minute. That's how it ventilates its engines. It's always very dusty in the open pit, so changing the filters is one of the most frequent and most necessary maintenance operations for this monster. Otherwise, it is surprisingly low maintenance. Now, the gas torch section is somewhat like a tailor's cutting table. Only instead of scissors, there is a high-temperature flame, and instead of fabric, there is a thick sheet of high-strength steel. Moving along special templates, the gas torch cuts out parts of absolutely any shape. Everything that's trendy and in season, so to speak. The parts are sent for further treatment, and the so-called trimmings are melted down. In the next section, the huge steel plates are being prepared to assemble the body for the dump truck. I would call this place the origami section. Only the sheets aren't made of paper, but thick steel. Otherwise, everything is the same. The work pieces are bent till the necessary figure is acquired, but this is no simple bending, of course. It's bending with this huge press possessing a force of, I shudder to say, 1,000 tons. The specially bent sheets are then joined together on very large welding machines. Also, the dump truck body is not completely assembled at the factory, as it would simply not fit on any railroad platform, and it would be impossible to deliver it to the open pit. The largest part of the BelAZ is made of 3 parts. The left side, the right side, and the center part are manufactured separately. The customer then assembles them into one whole right on side of the quarry using ordinary bolts. This part here, which looks more like a huge bell, is actually just a gearbox cover installed on each wheel of the BelAZ. Basically, this monster doesn't do things in small sizes. Even the size measuring tool is threateningly big. For example, this is how a machinist's micrometer looks. The wheels for the BelAZ are made at another Belarusian plant in Babruisk. It was specially built to supply tires for heavy quarry equipment. The wheel of a 220-tonner is a one-off product and therefore almost entirely handmade. To create the so-called bracelet, the rubber base of the future tire, sheets of synthetic rubber are fitted together by hand. Layer by layer, the workers build up the base of the tire. Several different grades of rubber with different properties are used here. After vulcanization, they are all sintered into a homogeneous mass. But in the meantime, the bracelets are put on a hollow mold, one by one. To pull every subsequent bracelet on this drum mold, there is a special device here which is called an expander. The name speaks for itself, of course. Here you can now see it. It simply stretches our workpiece and puts it on this drum here, like women's tights slip onto a leg. The edges of each subsequent bracelet are tucked into the sides of the workpiece in a special way. Here, at the end of the future wheel, the so-called wings are installed. These wings are discs of especially strong steel, which will then hold the wheel on the hub. As a result, a rubber tube is obtained, which will become the inner base of the tire. Now it must be covered with an outer layer of particularly strong rubber, which after heat treatment will become the tread of the tire. For this purpose, a special mixture of rubbers is melted and mixed in a device that resembles a meat grinder, and then pushed through a so-called extruder in the form of a thin strip. After that, the rubber strip is cooled down slightly on this water-filled drum, and then it passes onwards. Ultimately, it is wound on this workpiece like a thread on a spindle. In fact, the weight of this thread is over a ton, while the weight of an assembled wheel is about 3 tons. The rubber is 15 centimeters thick, for the tire of this monster must withstand the most incredible loads. To turn this rubber tube into a workpiece, which already resembles a car tire in shape, it is molded, i.e. compressed on both sides and simultaneously inflated with air. Approximately the same thing we do when we inflate a rubber balloon. The only difference here is that the pressure inside is a little bit higher, about 3 atmospheres. It's about the same pressure we have in our radiators at home. After molding, the workpiece already acquires an appearance close to that of the finished wheel. However, now it's just a layer cake containing different grades of commercial rubber and steel wire. And it's a soft cake at that. For the wheel to be able to withstand the weight of a huge BelAZ, it needs to be vulcanized. This process takes place in huge ovens called autoclaves. You can easily imagine a shortbread cookie mold. Well, it's the same idea here, only a little bit bigger. The tires end up with this tread pattern imprinted on them, and even the lettering, well, obviously, it's sort of mirrored here. It's all just like in the kitchen, save for the weight of this cookie being 3 tons, 300 kilograms. From a chemical viewpoint, during vulcanization, the disparate molecules of rubber are built into a single spatial grid. And these molecules are connected by what are known as vulcanizing agents. Most often this is carbon, i.e. ordinary soot. The wheel workpieces are loaded into the autoclave in a stack, one on top of the other. From above, the furnace shaft is closed with a multi-ton casing, and that's it. Now, all that's left is to wait. The process takes 12 hours, give or take. The finished wheel is thoroughly and meticulously inspected to root out the slightest defects. And this control is not only visual, each tire is X-rayed. It must be perfect both inside and outside. Only in this case will the tire be able to work for years and repeatedly return to service even after severe damage, as was the case at the Western Siberian coal mine. The absolute record time for changing all 4 wheels on a car is 2.5 seconds, which was set at a pit stop during a Formula One race. But here they set their own records. This wheel assembly here, weighing about 5 tons, just takes 10 minutes to install. And here, by the way, there are 24 nuts, each measuring 41 millimeters in diameter. The nut driver generates a force of several hundred kilograms. In fact, the wheels are installed in the shop only to test run the machine, as a huge dump truck will go to the customer in parts. The tires alone take up a whole railway car. The BelAZ's brakes are disc brakes. We can say pretty standard vehicle brakes. 2 pairs of pads. When you press the brake pedal, the pads compress this disc and thus stop the wheel. But the force of this compression is astonishing. It's several tons. To stop such a hulk, you have to use a lot of energy. But even more energy is needed to make this wheel rotate. The motion is transmitted to it through a huge gearbox. It's mounted on each wheel between the electric motor and the hub. Its job is to increase torque. In other words, it turns rotational speed into rotational force. The gearbox is assembled here on a special slipway. Here, gears, shafts, bearings, and so on are installed in its housing. And the assembly accuracy is so high and all the parts fit together so perfectly that, for example, this gear wheel, weighing over 100 kilograms, can be spun without any effort using just one finger. The two BelAZ traction motors on which these gearboxes are mounted consume 1,400 kilowatts. That's enough electricity to light 23,000 light bulbs. Owing to such an amount of energy, this machine is powered by a huge diesel engine. The heart of our monster is this very powerful engine. However, it works in the same way as a normal passenger car. On internal combustion, the cylinders are V-shaped, but here we have slightly more of them, 16, and the volume of each of these 16 cylinders is almost 4 liters. The engines used to be made here in Belarus, but today they are purchased in Germany and the USA. It is hard for one small country to build such a big machine. This plant now has many suppliers all over the world. Meanwhile, the BelAZ truck is hauling the Belarusian economy on its back, in every sense. If you think that the maintenance of your car is too expensive, then keep in mind that the maintenance of this monster costs about 100,000 US dollars a year. Although, no surprise there. For example, to inspect the engines, it's not enough to open the engine compartment. You need to climb inside. Reliable, simple, trouble-free, like a Kalashnikov assault rifle. This dump truck can work for years in the most severe conditions. This coal mine in Western Siberia and hundreds of other open-pit mines in dozens of countries around the world know this very well. It is a bit clumsy. It lacks grace and elegance. It is almost always dirty and has an incredible appetite. But it mines coal. It's a monster with a very brutal temperament. But at the end of the day, it brings us light and heat.